Hello and welcome to the Kielder Observatory podcast for December 2021. I'm Ian Brannan, and in this episode joined by Director of Astronomy Dan Pye and fellow science communicators and astronomers Ellie MacDonald and Adam Shaw as we explore some of the things to look out for over the final weeks of 2021 in the night sky, including a comet. And we're also joined by a special guest, Dr. Olivia Jones of the Royal Observatory in Edinburgh, who's an expert on the James Webb Telescope, which launches very soon, hopefully, and when it does, it'll bring us a whole new view of the universe. She's an STFC Webb Fellow at the UK Astronomy Technology Centre at the Royal Observatory in Edinburgh and very much knows absolutely everything there is to know about the James Webb Telescope. Plus, for the first time, this podcast was recorded live in front of an audience on our Facebook page. You can actually watch it again if you head over to the Kielder Observatory Facebook page and look at the Facebook Live if you want to see us in person, but we did ask for some of your questions for Ask an Astronomer. But first of all, let's get an update on what's been happening at Kielder Observatory. As you'll be well aware, the weather hasn't been particularly kind, especially in the northeast of England, and Storm Arwen certainly did some damage across Kielder Forest. But the good news, if there is a shred of good news, that Kielder Observatory largely stood the test of what Storm Arwen had to throw at it. That is the case, isn't it, Dan? I think you emerged fairly unscathed. The bigger problem was the effect of the trees falling down along the track up to the observatory and the damage to the forest in general. But the observatory building did stand the test. That's right, isn't it?
Yeah, it did. I'm very happy to announce that. Yeah, it didn't slide down the hill like some kind of slalom that I expected it to be. It was it's fine. It's in one piece, still on its stilts. The only thing that actually broke was a little plastic shed next to the observatory, which was holding some of our grit. So aside from that, everything else is absolutely fine. The radio telescope's fine, the observatory's fine, and everything is back to normal, hopefully from tomorrow, in fact, we hope.
Yes, reopening tomorrow. Of course, if you've got tickets for that event, there are a few buts to that, aren't there, in that whilst the observatory is open, there are still some issues throughout the forest, because it was Kielder Forest really that was damaged. A lot of trees fell down. You might have seen some of the photos, and it was all a bit of a mess, but you're advised not to head into any of the forest. There is how it looked. That's the track up to Kielder Observatory after Storm Arwen, and that has been the main problem in that you couldn't actually drive up there, number one, but yeah.
Yeah, absolutely. All those trees have now been cleared out of the way, which is nice. And Forestry England have been absolutely incredible at getting people out of sticky situations and bringing Kielder back to the rest of the world as well, because being such a remote village, the most remote village in England, the people who lived there were without power for such a long period of time and, of course, weren't able to leave Kielder for a period of time as well due to the amount of trees down and the instability of those trees. So Forestry England have done an incredible comprehensive check of all of the trees in the perimeter of our track. And hopefully by tomorrow that'll all be satisfactory and we'll be able to reopen. Yeah, absolutely, everything is looking good. But the one thing to add is that yes, you can come to the observatory, yes, but you must leave straight away. Essentially, you can't go on any walks around the observatory. Unfortunately. Yeah,
just stay out of the woods for the time being because, of course...
stay out of the woods.
Not that at 1 o'clock in the morning you would be recommended to be going on a ramble round there anyway, but it's some of the trees obviously still unstable, so for safety reasons at the moment.
And all the aliens.
Yeah, well, of course, it goes without saying the aliens. We know about that. Let's have a look ahead to what's happening in the night sky then over the closing few weeks of this year into December now, heading into 2022. There is one particular event that I'm reading about, the comet Leonard A1. Or is it A11? I'm not entirely sure. Is it comet? It's Leonard. But this is what it looks like. That is going to be in the night sky and visible with the naked eye.
Yeah, so at the moment it is down to an official magnitude which is visible to the naked eye. Now it's going to require some specific sets of requirements in order to be able to see it with the naked eye. First off, it's got to be clear. Secondly, really what you want to do is be getting somewhere that is dark in order to be able to see it, because it is a very faint object to see. If you've got a pair of binoculars, then we want to be trying to point out this object just underneath the plough down towards the northeastern horizon just after sunrise.
Okay, so look out for that. That's Comet Leonard, which will be a fixture for the next few weeks or so?
Did I say just after sunrise there, or just before sunrise?
I think you said just before sunrise.
Yeah, that's the right thing. Just after sunrise, of course, that wouldn't work.
Yeah, you see, this is the thing you get with a live one. If it was recorded, we'd edit that bit out, but we can't. There is an element of doubt sometimes. And what else is there in there to look out for at this time of year for people who are looking, just in your garden, looking skywards? Of course, what's the things to look out for, and any planets we can see at the moment too?
There is, yeah. The planets are visible towards the end. Before dusk. Just as it's getting to dusk, we've got Venus over on the western horizon, and then we've got Jupiter and a bit of Saturn still kicking around as well. So you can look at those just after sunset. Sorry. And there is a couple of other planets up, but you're going to need a telescope in order to be able to see those. You've got Uranus, you've got Neptune, but definitely need a telescope for those ones.
Fantastic. Okay, so those are the ones to look out for. Of course, wrap up warm, because it is the chilliest time of year, really, for doing a bit of stargazing, but some beautiful clear skies as well. And I've had a few pings, too, of the possibility of aurora. Have we had any confirmed sightings over the last few weeks or so? Because my app that we're advised to have sort of keeps suggesting that there might be half a chance.
Yeah, so there was a ping. I think, was it yesterday?
Yeah,
and it was a problem with the magnetometer, so it wasn't really
right.
a ping. It's probably someone mowing the lawn again. That's what happened the last time. So
was that right?
Yeah, it was once triggered by a lawn mower at some point in the past. So maybe it was just that again. Although I can't imagine anybody was mowing the lawn at this time of the year.
Well, you never know. You never know. There's always probably somebody.
Gremlins.
Yeah. Now, one of the regular features, if you've not listened to our monthly podcast, Dan Pye, Director of Astronomy, likes to give you a little challenge. So something a little different to look out for in the night sky, maybe slightly more advanced. Maybe you've got a telescope or a decent pair of binoculars and you want to head deeper into the night sky. In our feature, Pie in the Sky.
Oh, look at that.
So, Dan, give us something that's going to stretch us a bit over the next few weeks. Something, over those Christmas days where you've got your holiday and you're off work and you've got a nice clear sky, one of those quiet days between Christmas and New Year that nobody knows what to do with. What should they be looking for?
I'm going to give you a star. This is, can I just add at this point, actually, usually when we're recording the podcast, this is me scrabbling around to try and find an object because I haven't pre-planned. But knowing tonight was live, I have pre-planned. So yes, a Christmas star, we'll go with that. And this particular Christmas star is it's my favourite star, actually. I'll let you into that secret. It is called Iota Cancri, or its Hipparchus catalogue number is HIP 43103. Which is the only Hipparchus catalogue numbered star that I remember. But it's a beautiful star because it's not, when you look at it, it's not one star. It's in fact two stars. It's a binary system. A little orangey, it's a yellowy kind of coloured star, and a little blue star, which are orbiting around each other. And it looks incredible through a telescope. Really, really nice. One of the nicest binary systems I think you can find. And to locate it, you need to find the constellation of Cancer, which is quite a difficult one to see from a light polluted area, actually. But if you get somewhere a little bit darker, or you've got a moonless night, then if you locate Cancer, you'll be able to spot this little star just at the very top of the constellation. You need to be out late at night as well, because of course Cancer is rising much later in the night. But if you're out during the night, HIP 43103, that's where you want to go to. Beautiful.
HIP 43103, and put that catalogue code in Argos, and you probably get an ironing board. But something to look out for over the coming weeks or so. That's this month's Pie in the Sky. Let us know how you get on. And right now, we're getting ready to speak to our main guest in this month's episode, Dr. Olivia Jones. Dr. Olivia Jones is of the Royal Observatory in Edinburgh and is an expert on the James Webb Telescope, which launches hopefully soon. And when it does, it's going to bring us a whole new view of the universe. She's also an STFC Webb Fellow at the UK Astronomy Technology Centre at the Royal Observatory in Edinburgh, and previously has worked at institutions such as Jodrell Bank, and so knows lots about the James Webb Telescope, clearly, and much more besides. And she's going to tell us all about it, because I'm going to show you a picture of the James Webb Telescope first of all, because it's an impressive bit of kit. There it is.
Whoa, look at that.
It looks like properly something out of Star Wars, that, doesn't it? And
with its Baco foil.
Yeah. And now this is going to change our lives over the next however many years, and Dr. Olivia Jones is going to tell us more about this, because when this goes up, it's going to see into parts of the universe that currently sat here right now we don't even know exist. And it's going to answer many questions, and probably create many questions as well. And the thing about this is that quite a lot of research and work has gone on here in the northeast to help out with this. And Durham University have certainly contributed some of their thoughts on the optics that are aboard this, that are going to bring us this view. Dr. Olivia, welcome to the Kielder Observatory podcast. And start by telling us about the James Webb Telescope. It's long overdue. It should be in space already. Hopefully it will be going into space shortly. Firstly, explain the delay, because I think obviously COVID is probably one part of that, but what's the rest?
Oh, well, thanks for the easy question to start off. Hello, everyone. James Webb Space Telescope is a fantastic, amazing piece of technological astronomy hardware. And it's going to revolutionise our view of the universe. It's been long awaited. I've been working on it for about 8 or 9 years now, and I've been wanting it to launch for quite a while. I don't know if you fully appreciated from that picture just how big Webb is. Its mirror is around 6.5 meters in size, and the silver bit is the sun shield, and that's about the size of a tennis court. So we're looking at an absolutely humongous telescope that's being launched into space. And one of the main challenges of launching one of these telescopes is just how do you fit a telescope bigger than about the size of a tennis court, plus the mirror, into a rocket which is 4.5 meters across.
And how do you do that? And how do you do that?
You have to fold it all up. And so one of the reasons why Webb has taken so long to develop is its technologies need to be, from concept to actually, we've developed a lot of technology along the way to making it launch. And not only that, it's not going to be launched to around orbiting the Earth. We're going to be at a place called L2, which is a stable orbit 1 million miles away. And so at that point, it's great for telescopes like Webb, because that observes in the infrared, not at optical wavelengths, because it's further away from the sun. But you have to make sure you get it right. And so a lot of what we've been doing with Webb over the years is shaking it, rattling it, rolling it, doing everything we can to make it as robust as possible for its mission, which will be starting on the 22nd of December, hopefully.
Fingers crossed.
So that goes in way to explain the delays. We've tested it thoroughly and tested again and tested again.
And give us a comparison, because obviously people will be familiar with Hubble. If they haven't seen it, they'll have heard of it because it's been around so long. But what is the upgrade here from Hubble to the James Webb?
Okay, there's two major differences. One is the size of the mirror. Hubble's mirror is around 2.5 meters in diameter. It's about the size of a double-decker bus, which is great. But that means you don't have as much collecting area at Webb compared to Webb's mirror, which is going to be 6.5 meters in size. The bigger the mirror, the better you can see, and so new discoveries are always found. The other main difference is that Webb will not be operating at exactly the same wavelengths that Hubble operate. Hubble works at the ultraviolet, the optical, and a little bit of the infrared, whereas Webb will operate at some wavelengths where Hubble operates, but it'll operate at slightly longer wavelengths. So it'll see a bit of the cooler universe than what Hubble will see. So the areas where it does overlap Webb is significantly more powerful because it's got a bigger mirror. But those longer wavelengths let it see further away, and hopefully it was designed to see the first light in the universe.
Yeah, that's one of the many things that people are excited about, isn't it? Being able to see the first light, which is absolutely incredible considering how old the universe is, that we might still get these echoes of the Big Bang and see them. What are the other things that you're excited about, particularly if in the long term that you're hoping it's going to bring?
So there's 4 main science themes of Webb. There's the very first light in the universe, which will be around 200 million years after the Big Bang, is where we're hoping to get to. So not quite the Big Bang. You won't be able to see stars because stars didn't exist then. But 200 million years after the Big Bang is what we want to see. We want to then also look at how galaxies assemble. We don't actually know how galaxies like the Milky Way changed over cosmic time. Lots of galaxies crash into each other, they collide. There's lots of stuff going on. So you want to learn about how galaxies are made. Do they form as like little bits and then collide together and get bigger and bigger? Or were they just big? We don't know that as a question. In a similar theme, when the universe was first born, there was hydrogen, helium, and a little bit of lithium in terms of the elements. So all the gold you see around you, if you've got a ring on, you've got some jewelry, all of that was made by the stars. All the carbon, the oxygen, everything. And so as the chemical evolution of the universe is something where Webb will be very powerful. The other areas where Webb is going to look at is the beginning and ends of a star's life. Personally, I'm involved in lots of programs to do with how stars are being born and how stars die. And then the other final science theme of Webb is looking at the atmospheres of exoplanets. So these are planets orbiting nearby stars, and hopefully we'll be able to see what sort of chemical signatures their atmospheres have. Do they have methane? Do they have carbon monoxide? Do they have lots of gases? And hopefully that will tell you much about life-bearing planets. That would be an ideal case scenario, is learning about those. So there's lots of exciting science that's going to be happening across from the very early stages of the universe to right in our solar neighbourhood.
All I heard was aliens. Sorry, Olivia.
No aliens.
Yeah, aliens.
Definitely aliens.
No,
that's what I'm most excited for, to be honest. What it's able, not necessarily the alien side of things, but just being able to learn about other planets around other stars, learn about the atmospheres, and maybe finding aliens, just a little bit of aliens, finding the biosignatures.
I'd heard that the sensitivity of the James Webb Space Telescope can see the heat signature of a bee at the distance of the moon. Is that a confirmed fact? Is it? Because I've quoted that and always wondered, actually, am I quoting nonsense?
I've heard something very, very similar. Webb in the infrared is absolutely mind-blowing. The technology involved to do this is stunning. And the great thing about this, compared to any other telescopes that operated in the infrared before, it doesn't have any coolant involved. Previously, that's what limited the lifetime of other missions. Is you need to be really cold if you were observing in the infrared, because that's the heat radiation. So Webb is extremely sensitive to anything you see around you. So you have to get really, really close to where atoms don't move at all. And Webb does this in a very clever way with the sun shield of the radiation bouncing out of each layer. And then the mid-infrared instrument, which is the one that is led at the UK Astronomy Technology Centre and then has a massive UK involvement, is actually then cooled even further than the rest of the instruments on Webb. So yes, you probably could see a bee on the moon. The sensitivity of this telescope is amazing. So yeah, you can say that to all outreach talks forever onwards. You can.
Wow, a bee on the moon. Ellie, what would you like to know about the James Webb Telescope?
Well, I mean, specifically with the mid-infrared instrument, I was just wondering, what is that? What do you hope to learn with that? Because presumably you're not going to be looking at bees on the moon.
It will answer your alien question. If there's a bee on the moon, I want to know about it.
That would be a great level of effort to go to just to look for bees on the moon, wouldn't it? But
moon honey. That sounds like a brilliant product line.
Yeah.
Why not?
So yeah, the mid-infrared instrument is the one that operates at the longest wavelengths on Webb. There's 4 instruments, 3 of which operate at slightly shorter wavelengths, and the mid-infrared instrument MIRI, which operates at the longer wavelengths. And that's really good for looking at the cold objects. So the stars that are being born, the stars that are dying, the really redshifted galaxies. And by redshift, so I don't know if you hear sirens of police cars or ambulances, as that wavelength changes as you get close to you. That's a similar effect you see across the universe. And so the very early galaxies are redshifted so far into the mid-infrared, that's where we should pick them up. So that's where we hope to detect the first light. So yeah, and also planets forming around stars. That's a perfect area for the mid-infrared instruments. So that's what you get then. There's like an ice skater spinning around, and that forms a disk. I don't know if you ever tried spinning around fast and then moving your arms together and then further apart. It's lots of fun. But a similar happen things when stars are born, and they form this planet-forming disk around a star, and hopefully we'll be able to observe that around many systems nearby. And that would be excellent science, and hopefully science will be doing early on as well.
That'd be cool. That'd be so cool to see, actually.
And what's the actual duration of this mission then? The intended duration, because Hubble has been in space now for a very long time. And what's the life expectancy of the James Webb Telescope, really?
Yeah, Hubble has been absolutely amazing at how long it's lasted, about 30 years, which is stunningly awesome, given it was meant to have quite a short mission lifetime. So Webb is meant to last at a minimum of 5 years. And then with about 10 years is what we're really aiming for. Though the people who run Hubble are also going to be running Webb. And so they're going to be very careful about the lifetime. And so I expect it to hopefully last much longer than the 10 years. But 10 years is what we're aiming for. What limits that lifetime is how much fuel it will take to get to its position after launch. If we need to do a course correction and burn the fuel up, that will take away lifetime of the telescope. So I'm quite nervous for the first month after launch as it's traveling. The telescope is traveling and folding to its L2 place, the 1 million miles away. That will actually determine the lifetime mostly of Webb. And because Webb is big, any observations you move around the sky require fuel. And so that eventually, when Webb can't move, that's the end of the lifetime when you can't change it. It has a lot of momentum. It's like a big giant truck that you're trying to drive with limited fuel, and eventually you'll run out.
With any space mission, obviously there's very nervous times when it comes to the real event, and this telescope has to unfurl quite a lot to get to its full potential. We've seen like Mars missions, obviously moon missions, and you don't really know it's going to work until that actual moment, and hugely nervous time. What preparations have you done, and what practice have you done to sort of rehearse for this as best as possible for this big moment of hoping it all goes smoothly?
Well, for my nerves, I've watched a lot of football penalty shootouts. But for the telescope itself, we've done a lot of shaking. We've put it in cryo coolers, so we've cooled it down a lot. We've used a lot of the testing chambers that they actually used for the Apollo missions, because they're the only things that are big enough to hold Webb. It is a really, really big telescope, just in case that hasn't quite been conveyed, it's big. So yeah, there's been a lot of cooling and warming up. There's been a lot of unfolding the mirror, because all those side bits, the 3 hexagonals on either side are folded away, and that big secondary mirror that has the 3 triangular structures at front is all folded up as well. If you can ever see any pictures of this, it's a stunning piece of engineering and compact. So that unfolding mechanism has been tested God knows how many times, a lot. The unfolding of the sun shield has happened about 3 or 4 times. We try not to do that too much because we definitely do not want that. That is very key for Webb to work. So there is 30 days and there's about 300 movements of Webb that has to take place in that 30 days. And in principle, if you launch something into space, you want to have as less things that move as possible. So this is very nerve-wracking, seeing all these things have to work and unfold, and probably in our lifetime we won't see another telescope this big launch, just due to how technologically complex it is. And yeah, it's slightly terrifying that all these have to happen. So launch is exciting, and that's the first thing that should hopefully go very well. But then, there's 30 days where all these movements are happening. The sun shield unfolding, all the origami movements. We've studied this extensively. We've tested it extensively. But if you can imagine, all those layers are all folded up and compacted together and folded up next to the mirror. That's a lot of movements that have to happen. And the very first thing that has to happen is the sun solar panels have to come out because it's running on battery until that happens. And so the rest of the movements can't happen until we get off battery power as well. So it's exciting. We won't see this happening, but we'll be studying this from all the telemetry detail as it moves away from us.
And what was the thinking behind the sort of hexagonal, the mirror? What was the design thinking behind that? Because it sort of reminds me of the Blockbusters board. I'm sure it's more complex than that.
Well, no one's asking Bob for any letters, I don't think, this time.
Good.
Most telescopes, when you reach a certain size, even ground-based ones, start to become made of hexagons. You can no longer really make a mirror that well after you've hit, because in the surface of these mirrors need to be absolutely polished to perfection. Here's another stat for you, a bit like the B one. If you put the mirror surface, you made it the size of France, you would only have a very, very small, and I mean very small, little incline in the gradient of just how flat it was. It'd be the size of France. You wouldn't have even have a little mini hill. It would be more or less completely smooth, which is stunning. I think probably even like the hill on the Champs-Élysées, it's less than that. How finely flat those mirrors are polished to, which blew my mind. It has to be engineered and polished to perfection. So you can't do that with one ginormous mirror. And you definitely couldn't get that into a spacecraft. And what this allows you for, hexagons, you can align them all individually. So each one of them has got little motors, and when we're in space, we'll be pointing at a star, some very bright stars to start off with, and we'll be aligning all the mirrors to make our telescope go in focus. So this is not a telescope that will need glasses. We will focus it on the stars themselves by aligning each mirror perfectly.
Fantastic. Well, hopefully it all unfurls in the right order, and it could make for a very. How long after the launch would you be talking about this process of it all folding out and the origami happening in space?
It starts off hours after launch. It takes 30 minutes to get up out of the atmosphere and all the separation to occur, and then the unfolding starts within a few hours. Antennas, the sun, the solar panels. There is a fantastic video showing this. It's slightly terrifying because it used to be played on loop in the tea room. And given how I know these have to work perfectly, it's marvelous and wonderful, but a little bit scary for people who are heavily involved in this mission. And it shows the key stages of where in the orbit it is moving away from us, and the stages that need to unfold at each day. So I'll advise people to try and check that out.
So it could make for a fairly nervy Christmas for you if it does go up on the 22nd of December then.
Yes. At one point, I was scheduled to be in mission control for Christmas Day, but luckily that's changed. But several of my colleagues are there studying, making sure that each of these bits happen in time, and it's all being checked out and working correctly as we go. It's all hands on deck from just before lunch.
Wow, that would be a way to spend Christmas, wouldn't it? In mission control, but not one that you'd want to be enjoying a full turkey dinner during, I wouldn't imagine. But all the best with it, and fingers crossed it does all go ahead on the 22nd of December. If it doesn't happen, then what's the next launch date? Do you know?
The next launch date will be the 23rd of December. It always happens around 20 past 12, so lunchtime. That's the optimal launch window from French Guiana. So if for some reason it's not the 22nd, it'll be the 23rd, and it will just carry on then. So it should be before Christmas, and I expect it to be the 22nd completely.
Okay.
The telescope's being moved there, being put on the rocket as we speak.
Wow. Okay then. So it could be good for going. Just a couple of weeks' time. Fantastic stuff. Anybody else got any questions for Dr. Olivia before we move on to Ask an Astronomer? But there are some questions for you, Olivia, about the James Webb Telescope coming up. I've seen. So don't go far. But Adam, do you have anything or?
Yeah, I do. So obviously you're talking about the mirror and how absolutely impressive it is. But when you see the photos of it, you can obviously see that it's a lovely gold colour as well. I believe is it some sort of thank you for the picture there to help illustrate. So I think it's like a gold. Is it a gold beryllium sort of alloy, or something along those lines?
Okay. There's about 6 or 7 equivalent wedding rings worth of gold on that mirror. It's a really, really thin layer of gold on the top. Wow. So yeah, not many wedding rings needed, but a few. Probably less than 10, so you can fit them all on your hand if you wanted to. And then actually underneath is beryllium. And so beryllium is very, very stable at cold temperatures. And that's why, so it's light. There's 2 key things, the light, and it's stable as you get to much cooler temperatures. And that's what you need if you're going to be observing and cooling the telescope down to close to zero, as absolutely zero temperature as possible. So each mirror segment weighs about 20 kilograms plus 20 kilograms of electronics. So they're big. Those mirrors are big, but they're actually very light as well. So yeah, mostly beryllium, mined in Utah, and then a little very thin layer of gold on red.
Wow, that's incredible. I didn't realise there was so little gold on the top there, but I mean, I guess it just makes sense because you need it for the reflective side, don't you? And then, wow, awesome. Thank you.
Top stuff. Okay, well, we'll go through some questions now because on our Ask an Astronomer section, we've been asking you to give your questions, and we can move on to some of those right now. And I think there's something for everyone here. Adam, you are the education lead, and we have a question from one of our younger viewers. This is Seb, age 7, who asks, how fast are meteors?
Oh, that's a fantastic question. So they're going really, really quick. It does depend on sort of which direction they're coming from, but they can be traveling 10, 20, maybe 30 miles a second. So they're going incredibly, incredibly quickly. And you definitely wouldn't want to get hit by one, to say the least. But that's a really good question as well, because we are coming up to the Geminids meteor shower just in a few days. In fact, it's going to be peaking Monday night, early hours Tuesday morning, and it's going to be absolutely fantastic. We can see up to 100 meteors an hour. But yeah, so they're going incredibly, incredibly quick. And if you go outside Monday night, fingers crossed for clear skies, you might be able to see plenty of them up in this nighttime sky. Okay,
so there you go, Seb, and that's good news that you might be able to see some meteors very soon. By the way, if you want to ask a question to one of our astronomers, please do. All you need to do is just type in the comments at the bottom of this post, of this live feed, and the questions will come straight through to us here. Next, one from Richard Lewis who said, visited the Obsie in August. It was raining. We've all been there. Stayed in Kielder for a week, and eventually it cleared and beautiful skies. That is something, but we do have now, we mentioned earlier, the new radio telescope, which certainly gives you now the opportunity to do some observations, even if the weather does come in, doesn't it?
Yeah, it does. Yeah, I mean, we can. There's loads of things that we can point out radio antenna to. I must kind of set an expectation on that, though. It takes a very long time to take an image with this particular piece of kit. If we were taking any kind of image that we take is not a conventional image, so it's not something that is in visible light. Of course, this is radio frequencies. They're non-visible light, and the resolution of it is really, really, really bad. So we're talking like 1 degree per pixel, which is quite a lot of sky. That's like double the width of the full moon per pixel, and we might only do something that's 10 pixels by 10 pixels, and that can take 45 minutes to do. So essentially what we might get is a lovely colourful splodge. But that lovely colourful splodge could be radio signals which we've picked up from something that's a couple of 100 million light years away. So it's an interesting splodge, and nevertheless still light in the same sense as well.
And you also get detail of you can look at analyze gases and obviously you mentioned radio frequencies and much more as well. So it's not just about what you can see; it's about what you can hear and almost taste, perhaps in space, if that's the right phrase. I'm not sure it is.
Can we taste in space?
Well, yeah.
Well, I've never tried it.
Hey,
I've certainly never tried it. I would, if I was given the opportunity.
I would always say, don't knock it till you've tried it.
Well, right.
Let's move on. Man on the Toon says, when will the galactic centre of the Milky Way be visible from Kielder next year? It's a good question because it's a great time for astronomers, but also astrophotographers, of course. It makes for a great photo, doesn't it?
Yeah, it does, and I'm going to shatter everyone's dreams with that and say, unfortunately, it's not really. It's slightly below the horizon for us at Kielder, certainly out of our view at the time of the year when it would normally be visible. A good time of the year to see the Milky Way is between June and September. But for us in the Northern Hemisphere at 55 degrees north, we experience our lighter nights during that period of time as well. So we do have a very narrow window of opportunity to just graze the top of the center of our galaxy during June and then towards the back end of August into September. But we don't get the true good, really substantial central section that you would get if you were to go somewhere like Tenerife, for example. Then it would be at a really good observable distance above your head there.
Okay, but yeah, you still do get a decent view of it, I suppose, don't you? With the dark sky, it's just as you say, you've been to. I mean, you've been to. Was it Tenerife? You've got a great photo of it, haven't you? And that was down there. Obviously, the further down south you are, the better the view.
Yeah. Yeah.
If you would like to ask a question of our astronomers, by the way, anything to do with space whatsoever, I asked Dan when I had a little rehearsal. I said, "Why are there no square planets?" Just as something as a ridiculous question. I got a full in-depth answer. So there's no silly questions.
I think it was one word.
Well, it was a long word, and it impressed me. So any question at all about space, the night sky, the universe. Whatever. Just in the comments, just type us a message and hit send, and we'll work our way down to it. Here's one for astrophotographer fans. Looking to buy my first astro cam. Should I go colour or mono? It can be quite confusing. Can you help Richard out?
It is definitely really, really confusing. I would probably recommend going colour to start off with, especially if you are in the UK, because if you wanted to get a pretty colour image and you got a monochromatic one, then you're going to need to have 3 times the observations, because you need to take photos in a red filter, a blue filter, a green filter, and combine them all together. So you kind of need 3 times the amount of clear skies, essentially. So if it's your first camera, then a color camera is probably going to be the best place to start with that regard. But either way, it is going to be a bit confusing when it comes to playing around with the software, and depending on what kind of camera you do get, often these kind of cameras, the images, the pixels are sort of all combined together when they come through the image, so you have to use software to what's called debayer it and combine it all together to get it all coloured. But I'd recommend colour for your first one, at least. Kind of dip your toes in, and then once you become more used to it, go for the mono, get some filters out, or you'll get some beautiful results.
Okay, so there's your advice there from Adam. I hope that helps, Richard. If you would like a question answering from one of our astronomers at Kielder Observatory, or you've got any questions about the James Webb Telescope, then please just drop us a little comment and we can answer that for you, because we've got 3 astronomers, including Director of Astronomy Dan Pye. We've got Ellie MacDonald and Adam Shaw with us, and Dr. Olivia Jones, who is somewhat an expert of the James Webb Telescope. And here is a question for you on that front. It says from Bill Hadley, what can we expect of the new telescope in terms of visual representations, like photos, similar sort of visuals to Hubble, or more scientific? What are the images going to look like, do you think?
They are going to be absolutely stunning. They are going to be comparable or maybe slightly better than Hubble, depending on the wavelength we're operating at. So the shorter wavelength ones in particular are going to knock our socks off. They're going to be comparable to Hubble at least, and combined, the Hubble and JWST images combined, I cannot wait to see. when I was picking some of my targets for Webb, and I had a choice, and everything all being equal, I picked the prettier galaxies, because I knew they were going to absolutely produce some stunning images. I hope to see many of my stuff in calendars in the not too distant future made by NASA. The images are going to be amazing, because we're going to have that very high resolution view across a very long wavelength range, and that will give us, we'll be able to see very different things, and the things that you definitely can't see with Hubble, like dust that are all dark, you'll see lit up in the infrared at that high resolution view that Hubble produces. So yeah, it should be very similar. They'll all be scientific as well, but it'll be beautiful, and I cannot wait to see the first images produced. I'm very excited by this.
There you go, Bill. It's going to knock your socks off, the official words on behalf of the James Webb Telescope mission there.
Just to add to that question there, Olivia, what's the field of view of the James Webb Space Telescope?
It depends on which instrument. There's 4 instruments, but it's much smaller than Hubble. So you won't be getting... There's amazing maps of nearby galaxies, for instance, that have taken a long time to do, but the field of view for Webb is much smaller. So you'll really be targeting specific things rather than all sky or big area mapping. What you will get is one of the images to really look out for, one of the early ones, will be the Webb ultra deep field. So like the Hubble deep field, where you may have seen where all the galaxies are, the Webb view of that should be absolutely amazing, because we're going to point at the same area of sky, but because of the sensitivity of Webb, we'll see many, many more galaxies, and also at this very high resolution Christmas. So I cannot wait to see that image being released. I'm not a cosmologist. I don't work on that science side, but that image I'm looking forward to. I've seen simulated versions compared to Hubble, and they are stunning. So I'm very much looking forward to the real thing when that comes down, and that should be mid next year or so. So
that's exciting.
That's going to be so exciting.
Yeah, something else that I wanted to sort of add on to that question, not to add on to an add-on, but you mentioned dust. And I know that a lot of your research has been to do with dust, and presumably that's not like the same type of dust that I have in my house. I was wondering if you could talk to us a bit about cosmic dust and what it is and why it's interesting and why you study it and what James Webb can tell us about it.
Okay, yes, I am a massive proponent of space dust. Space dust is awesome. It's not quite the dust you'll see in your house, though possibly not too far off what you might find on a beach. So space dust is very, very, very tiny particles. So you need to think about these as these are small, wispy particles of smoke. So some of this dust is carbon, and basically think of fine smoke particles surrounding some stars. Some of this is sand. So the sand you'll get on your beach, you'll find around dying stars a lot as well, and between the interstellar medium, the bit between stars. There's that. There's tiny little particles of diamond. There's 10 little particles of sapphire. There's 10 little particles of rubies. There's 10 little particles of olivine. So the olivine beach in Hawaii, I really want to go there. That type of sand is produced around dying stars, and what I did a lot of my research on. And I really want to go to Hawaii to see the sand. And that's what we mean by dust in space. Think of it as really, really tiny particles of mostly things like sand and soot. And PAHs, which is polycyclic aromatic hydrocarbons, or burnt toast. In other words, the burnt toast cell. If you see some very green images, potentially with Webb, that green is your burnt toast smell of the universe. So lots of carbons, and that's about star formation. If you see lots of that, that means a lot of stars are being born in your field. So yeah, I can talk about space dust for a very, very long time. You probably don't want me to. I'm very passionate about dust.
Itself. Yeah. the episode on dust and the smell of burnt toast. That's what we should do a follow-up.
Well, it was Bill that started this question off, and Bill's been back in touch simply to say, nice cat. There you go, Ellie.
Yeah, that was Pippin, I believe. There's Mary and Pippin. They both look the same, but you'll see them wandering around. But yeah.
Okay. Everybody likes a cat. Jacob has been in touch with us. Thanks for your question, Jacob. Are there any planets/moons within the Milky Way that have the same atmospheric conditions as Earth to support human life? Who wants to take that one on?
I'll go for that one. So, I mean, the ultimate answer is maybe. The James Webb Space Telescope will hopefully be able to find us that answer more definitively. There are plenty of exoplanets that we have found, that we have discovered, that we think might be similar to Earth. So they might be a similar size, a similar mass, a similar distance, or an appropriate distance from their planet where liquid water could exist on the surface for the kind of exact same atmospheric conditions. Well, that's something that's really exciting because our atmosphere, let's say the oxygen in our atmosphere, for example, we've got absolutely loads of that, but that's primarily coming and being replenished by life sources, things on Earth doing photosynthesis. So if we do find, and this is always thing about earlier on, but if we do find planets around other stars with lots of oxygen in their atmospheres, then that's one of the things that could be key and could suggest there might be life there. So they could support human life, but it could also be supporting other life in the first already. So fingers crossed we'll find something like that.
Yeah, because that's the big thing, isn't it? People think of human life, but and if you've not listened to any of our previous episodes on the Kielder Observatory podcast, and there's no reason why you would, but the very first episode we did, if you're going to go back through them on Apple Podcasts or Spotify and you search for Kielder Observatory, the very first episode we did was with Professor Wallace Arthur, who is an expert on all of this kind of stuff, and some of the things that he says there just are mind-boggling, in the fact that he said that almost certainly other life knows about us. He's absolutely adamant that there is life out there that's more advanced than us, that is aware of us, and we're fairly primitive as far as some corners of the universe go, and perhaps the James Webb Telescope he's excited for as well, because that might finally give him some answers on his hunch. But at the moment, we're looking at a microbe would be a massive discovery, because so far we've not found that yet anywhere. So humans doing their shopping in a Tesco in a deep, far-flung part of the universe would be quite a revelation at this moment in time. But yeah, the James Webb Telescope could. I don't know what would be the result on that. How would we find evidence, do you think, of life, Olivia, with the James Webb Telescope? Because obviously we've got probes on Mars at the moment digging down deep to see if they can find anything that might suggest that there's anything there. But with the James Webb Telescope, obviously we can see it beyond the moon, but what will be the goal deeper into the universe?
So a lot of the power of Webb is through not just the imaging, but the spectrographs. There's a lot of spectrographs, and that's when you break light out into very small components and look for chemical signatures. And so around the atmosphere of the Earth, for instance, there's lots of nitrogen, oxygen, carbon dioxide, and water vapor. What we're spending a lot of time on, especially early on, is looking at several nearby exoplanets and looking for things like the carbon dioxide levels, the methane levels. Methane in particular would indicate the presence of bacteria and microbes on a planet. If you see potential signatures like that, there'll be alien life on a planet. Potentially. I'm going to say many caveats, but looking for methane, which is in the infrared, with the spectrographs would be a stunning result. If you see carbon dioxide, that would suggest potentially volcanic activity. Water vapor would suggest it's habitable. And they're all things that we could pick up in the infrared where Webb will operate. There's ozone and stuff, but they're at shorter wavelengths, so they're slightly outside the range that Webb would look at. But yeah, methane would be a big one to be looking for. Okay,
signs of methane, carbon dioxide, and water vapor are all the things that we're looking for, and maybe we will find. Here's a question from Paul, again for you, Dr. Olivia. If all goes to plan, how long are we looking at to get the first pictures from the new telescope back to Earth?
Okay, it will take about 6 months. So what you first have to do is get it to its point in space. So that's 1 month. Then the sort of commissioning and aligning all the mirrors, that's another chunk of time. And then for all the instruments to be working, the mid-infrared instrument needs to cool down as well. So we're about 4 months in before that cool down has been completed. And then we can start calibrating the telescopes, making sure we've all tuned them right, everything is working correctly. And then about after launch, there's going to be a massive release of the first images, of which I really want to know what they are, and they're absolutely top secret. So I know a person who knows what's going to be taken first, but I don't know what that's going to be, and I won't find out until the same time as everyone else. And at that point, all that public is also, all that data is going to be released to the scientific community and the public at the same time. So if you wanted to, you could download that on the day that everyone becomes knowing what those first images and spectra will be. It's not just imaging. Spectra is a very, very big component of what Webb will do. Very powerful.
Okay, so that's going to be summertime, like June, July kind of time then, isn't it, when we're going to get that day? Let's get another question then from Paul Warren, who says, hi, how's Comet Leonard looking at the moment? What are the chances it'll be a naked eye visible comet over the coming weeks? Now, we did touch on this earlier, but I'm not sure we answered necessarily all of that. Comet Leonard then, we did mention it at the start, it's around over the weeks. Are there any periods where it gets brighter? Its optimum time, do we know?
Yeah, tomorrow morning is going to be its brightest. So tomorrow morning, just before the sun comes up, that's when it's going to be at its brightest. Actually, it's in the next couple of days. Actually, over the next couple of days is its brightest. Then it'll start to get progressively dimmer as the month goes on, as it makes its way away from us. And what's interesting about Comet Leonard is the fact that it's been travelling towards our sun for about 35,000 years. It's come from very far reaches of our solar system, and this object is now going to be ejected away from our solar system and potentially head off and never come back again. So this is a total once in a lifetime, even once in an eternity kind of visit from this comet. It may even become an interstellar piece of something that drifts on to find another solar system that some other humans gaze up at and go, oh, look at that, isn't that nice? And then it smashes into their planet.
Oh, that's what a crushing end
joking,
to that story, isn't it? But NASA have launched a mission, haven't they, recently to practice dealing with an asteroid, like the sort of real life practice for that Armageddon situation, haven't they? That they're working on at the moment.
Yeah, they have. They're going to go and punch it.
Yeah,
or nudge it. Only very gently nudge it. It's an interesting. An interesting scenario that's taking place, actually, because the particular asteroid is really interesting in itself because it has a little moon, and it's the moon that it's going to go and nudge, and that's going to be sufficient enough to hopefully change its course, only very marginally. And if we know that we do that and we can manipulate that, then it can help us prevent any further collisions with other pieces of space debris in the future as well, or asteroids such as this. Anybody got anything they want to add to that?
I mean, I think it's worth mentioning the name of the mission. It's called DART, or Double Asteroid Redirection Test. And if you're familiar with space astronomy, we love our acronym. So DART, that's pretty good as far as they go, to be fair. It seems slightly related with what its purpose is.
So look out for DART. But yeah, that's another quick question here from Sandra. Says, sorry, I've just come online. Is there a comet visible tonight? Well, it depends on if it's raining where I am at the minute. But yeah, and is there a particular part of the UK that you would get a better view of this, do you think? Or is it pretty similar wherever you are?
Yeah, it's probably going to be similar wherever you are because it's rising in the east. So yeah, it's going to be coming up in the east early hours of the morning. So yeah, pretty much across the UK, provided you've got a nice clear night. I don't think any particular part of the UK would do any better. It's quite easy to locate as well because you want to make a straight line down from the big bright star Arcturus, and that should be hopefully where you should find this little fuzzy blob of light doing its little outgassing thing as it makes its way away from our little solar system. Oh, isn't it nice?
There it is. So early hours of the morning, though. What sort of time would you be? Would you be looking at? to put a time on it? If you're going to set your alarm.
Yes, set your alarm for early. Keita, this is a part of the conversation which I haven't checked times on specifically, but we'll do that right now.
You do that, and we will ask this question: is space junk a concern when launching the James Webb? This is from Margie. Is that something we hear a lot about space junk, not just space junk, but Russians, of course, blowing up their own satellites certainly doesn't help. What sort of considerations are towards that sort of subject?
Yeah, space junk is a little bit of a concern nearby. Luckily, where it's going to be, it's not as polluted an orbit. If it was anywhere near the Earth, I would be terrified for that sun shield. It is very, very thin and very light. If you didn't want any asteroid or micrometeorite or any junk destroying any part of that. Luckily, where Webb is going to be, we're not going to unfold until we're far enough away to mitigate any concerns of space junk possibly getting in the way. What we are is in an orbit at L2. There was previous missions there. I won't call them junk, but those missions like Planck and Herschel actually were moved out of that orbit to keep that as pristine as possible and keep astronomy that would ever go there in the future as safe as possible. So yeah, space junk is a big concern of mine. Luckily, hopefully for this, it shouldn't affect the mission too much. We've tried to mitigate against anything that may cause a problem nearby.
Okay,
we need some sort of garbage collection for space, definitely in the not too distant future.
Yes, the intergalactic dustbin lorry certainly needs to be invented, doesn't it? But a million miles away is a fair distance out, isn't it?
It's really funny. There's actually a TV show, just to completely diverge from any point entirely. There's a TV show on Netflix called Final Space, which is an adult animation TV show. I love Final Space; it's brilliant, and it's been cancelled, and I'm devastated. But anyway, so during that, there is actually a spaceship which goes around collecting garbage. So there we go. It's in science fiction, therefore it'll be real in 20 years.
Good stuff. Let's.
Well, it's something they're trying to do.
Yeah. Is it? Well, they're going to need to, aren't they?
Yeah, like there's an awful lot of proposals on the board, from what I understand, and a lot of ideas being trialed about how we can actually go up and collect space junk, just to sort out the problems we've got. So it's something that I think could be a real reality very soon. Really.
There you go. Watch this space. Buy shares in space junk. Daniel says, can you recommend this? Maybe for you, Adam. Can you recommend the best stacking software to use as a beginner, and any recommendations to reduce trailing without spending a fortune on gear? A couple of issues there for the beginner astrophotographer.
It is hard. The Earth is so annoying. The fact that it's constantly spinning around, it really makes photographing the nighttime sky tough. So. Software-wise, I mean, it's going to depend on if you are a Windows or Mac user and such. I can recommend for Windows. Dan might be able to kind of recommend some stuff for Mac if you do have it on the Mac side. However, the software Sequitur, so spelt like equator but with an S at the beginning, that's great for stacking landscape kind of photography, because you can do things where you can freeze the foreground and highlight specifically just the nighttime sky. You can stack the sky separate, and I've been able to get some really nice results, and it's a completely free piece of software as well. If you are thinking about deep sky photography, then Deep Sky Stacker, that's a really good, powerful piece of software for deep sky photography, also free once again. When it comes to reducing trailing in the first place, for that you're just going to have to reduce the exposure time of your images. If you're kind of if you're taking photos with lots of too long an exposure, then you're just going to end up with trailing, and whether it be little sausage stars, like cocktail sausage kind of stars, or massive trails, either way, they don't look great. So what you can do is you can instead just have shorter exposures. You can crank up the ISO a bit, the ISO, and just stack lots and lots and lots of pictures. And if you do use software like Sequitur, you can use what are called dark frames as well, so calibration frames to be able to compensate for the noise, to try and kind of smooth it out. And so you can go for a higher ISO, which gets lots of noise, but you can then try and cancel it out a bit in post-processing.
That's one way of dealing with it. And then I suppose if you want to spend a little bit of money, you can get these mounts, can't you, that kind of track the night sky a little bit. But I suppose you're starting to spend a bit of cash there.
Yeah, so you can get kind of cost-effective ones. I've personally got one called a Skywatcher Star Adventurer Pro. It's a really powerful little piece of kit. I think it's about £300. Stick on top of a tripod, and takes a little bit of setting up because you need to polar align it with the North Star. However, you are able to get some really good kind of longer exposure images, and that way you don't have to worry about trailing at all. You don't have to worry about having to compensate with really high ISO because you're getting the longer exposures, you're collecting a lot more light. So you can get those star tracker things, and yeah, they're really good.
There you go. There's a few suggestions for you. We're taking your questions. If you want to chip one in, we'll probably getting towards the back end a bit, but if you want to sneak in there, probably last call for it, just to put a comment under the post here on the live video, and they come straight through to us. Glenn Carr says, will we be able to see the asteroid that's coming at the weekend? It's the comet, isn't it? This is Leonard. Now, Dan has done his research. What's the best time, Dan, to see this?
Yes,
you've got to be up early.
Well, actually, he's not wrong by saying asteroid as well, because there is an asteroid which is passing by this weekend.
Yes, the asteroid. Yes, everybody's panicking about that, aren't they? Certain tabloids.
I mean, it's fine. It's 2.5 million miles away from us. I mean, it's it's really, really far away. Yes, it's the size of the Eiffel Tower. Yes, it would make a dint, but it's really far away. So we don't need to worry too much about that. If it was coming towards us, we'd see it. All right. But the comet, from 4 o'clock in the morning tomorrow morning is a good time to head out and see it in your nightie or whatever you wear for bed.
Yeah, wrap up warm though, I would. So yeah, if you've got clear skies, 4 a.m. onwards, that kind of time. And the asteroid itself, that's going to be something that you're not really going to see, I would imagine. Is that right?
Yeah, that's right. Yeah. We're not going to see that. It's too far away, and it's just too small. I mean, you have to remember with asteroids and such like that, they are not very reflective things. They're very, very small in the grand scheme of things. I mean, the size of it. Imagine trying to spot the Eiffel Tower 2.5 million miles away, it not being reflective. I mean, it's just so far away and so small. No, it's not something we'll be able to see.
Okay, this might be one potentially for Dr. Olivia, but how are the growing number of satellites affecting our opportunities of viewing the universe? It's probably one for everyone, actually, because obviously Elon Musk is certainly doing his bit to change the night sky. But we just mentioned about the amount of space junk, but there's a lot of stuff up there. Does that affect our ability to view what's going on in the universe, either through our naked eye, through telescopes, through radio telescopes?
The short answer, I think, is yes. I think in the growing number of satellites, the trails that will impact, especially some of the large-scale astronomy surveys, like the Rubin Observatory, which is going to have massive, large fields of view, very sensitive. There's going to be lots of satellite trails, unfortunately, across those images, which will disrupt our view of the universe. Potentially less so with the naked eye, but not improbable that it will impact the naked eye observations of the sky as well. So it's quite a concern, I think, for the professional astronomy community. There are benefits for them, obviously. There are also cons, and I think I would err on the side of caution about launching so many large-scale satellite constellations in the sky. I'll let the other members maybe chat more about this.
How's it affected you, when you're looking and doing your observations through the telescopes at the observatory, in terms of the amount of stuff up there, particularly when you've had sightings of the Elon Musk project unfurling? It must make for certainly tricky for the astrophotographers when that's around. But have you noticed any differences?
Yeah, I think for us, it's for us, to be honest, when we see the satellites, I think that's a really great thing to talk to the public about. and them seeing satellites as well. It just gives you that kind of feeling and sense of these things are really high up there. They're going around us. It's almost like a feeling of depth on the sky when we see satellites, I think. So they're good for a few different reasons in terms of communicating with the public, I think. Yeah, for astrophotography, it's a bit of a pain to edit them out of your astro images, and you can spend quite a while with the spot removal tool trying to go along all of these lines to try and get rid of them. But equally, your aeroplanes as well. So in fact, aeroplanes are probably harder to get rid of than satellites are in some images. It's just, of course, there is more and more satellites. And as Olivia says, they are very, very useful as well. We are in a very remote location at Kielder. Some constellations can give us improved ability to connect to the rest of the world, and improve our internet connectivity would be really crucial for if we start to do any heavier work that may be asked of us through some of the projects that we're working on right now. So yeah, it has its they have their perks, and they're definitely interesting to talk to the public about. Don't know if anybody else has got anything to add on that.
I think you summed it up very well there, Dan. I mean, the way you see a train in the sky, it does look very, very cool. But from the photography perspective, from the imaging of the sky, it's incredibly, incredibly frustrating. Kind of the novelty, I think, is going to quickly wear off as more and more end up there.
Okay, on to the final question. It's a big one from James, who says, "Any predictions when the armpit will explode?" I assume that there is something to this.
There is, yes. So Betelgeuse is armpit. That's its name. Betelgeuse apparently roughly translates to the word armpit, and it is in the armpit of Orion. Well, I think this is probably just going to be a personal predictions. Personally, I like to just do the nightly Betelgeuse check that it's still there and hasn't exploded. That's always a very exciting, interactive thing to do on a night time. And then to try and use Jedi mind powers to get that to explode quicker. But I'm not entirely sure if Jedi mind powers move quicker than the speed of light. So I might be fighting a lost cause there. Anyone else?
May I? So that's one of the stars which I have looked at its dust in a lot of detail, and a lot of the Evolved Star community were very excited during its great dimming event, and I've listened to many, many talks on its future. And unfortunately, much of the great dimming was a combination of a solar spot and a dust formation event around this star. So I don't think it's going to explode anytime soon, but it's always good to check it's still there. It's one of my favourite stars.
Always good to check it's still there. And hopefully that answers your questions there. Peter says, "Many thanks for your insights tonight. Very enjoyable." Well, thank you, Peter, for joining us, and everyone else as well. It has been, I think we've made it through, which is not to be underestimated. Thank you to everybody who has given us a question, and I suspect we'll do this again some other time. But in the meantime, of course, if you do have any pressing questions on space, then you can always get in touch with the astronomers at Kielder Observatory on the social media pages, on this Facebook page, Twitter, Instagram, and I'm sure that somebody will be able to answer any of your questions at their earliest possible opportunity. What's the best way of getting in touch, Dan, if anybody does have any questions after this little broadcast, which is about to end?
Oh, so they can send them they could email us, obsy at kielderobservatory.org. That's OBSY at kielderobservatory.org. Or you can drop them through to our Instagram page, which is at Kielder_obs on... Is it that? Actually, now then. Is it that? Or is that the Twitter handle? Oh, that might be the Twitter handle, actually. Hang on a second. Here we go.
I think on Instagram we're just at Kielder Observatory.
Yes, we are.
Again, this is when we pre-record the podcast. These are the bits that we usually edit out.
Me, 90% of me. Yes, so it is at Kielder Observatory on Instagram, as Adam said, and at Kielder_obs on Twitter. So you could tweet us if you want to as well. Send us a message on Instagram. Our Instagram, to be honest, the messages, they get quite busy. So tweeting us is often a quicker way of getting an answer, or sending us an email. That's also a really good way as well.
And of course, hope to see you up there at Kielder Observatory at sometime soon. Quick update on the availability, because I know that a lot of the sessions are very full. I've had a lot of cancellations over the last couple of weeks, though, of course, with the fact the observatory has been closed. If people want to look into coming to visit us over the coming months as we head into 2022, the sessions are available to book now, aren't they, online?
Yes, all the way through to August, and soon to be added will be the latter parts of 2022 as well. We're just confirming the schedule of that. We're always trying to add on extra small events and such as well, here and there if we've got the capacity to do so. Obviously, we've had quite a lot of cancellations, which have been completely out of our control, and we're quite aware that we want to try and cater for as many people as we can. So any opportunity to do that. And of course, we're also doing these small ad hoc events every now and again where we just turn up in a park with a telescope and look at some stuff in space with dog walkers and things.
Yeah, I got a picture of that. There you go. There you are. Setting up.
There's Gregoire, and he's Is it Gregoire? Yeah, it is, isn't it?
Okay. Gregoire is the one with the red light on his head.
There he is. Yeah.
I'm behind the camera.
There you go. You see, yeah. So these little pop-up events that sometimes happen. So you just got to keep your eye on the social media pages. That's the tip. And as well, because with the way of the world, we do get short notice COVID cancellations. So if people can't make it because the old lateral flow or whatever is not permitted, then sometimes people do cancel at short notice, and they're usually shared on Facebook, aren't they, Dan? And people can maybe grab a short notice trip if you're able to make it with a couple hours notice.
And I think it's probably important to stress as well that the observatory operates with a lot of ventilation. Of course, we're outside. We're in a shed.
It's definitely ventilated.
Very well ventilated building. And we try and keep social distance where possible. Everybody has to wear a face mask inside, as is the guidance now anyway. That's always been the case for us. Regular cleaning all of the time, and reduced capacity to make sure that we are not overcrowded. So we do take it very, very seriously, as everybody should be at this precise moment in time.
And that's about it from us then for the Kielder Observatory podcast for December, and therefore for 2021 as well. Thanks for joining us in this episode, which was live streamed, the recording on Facebook, which is why that you'll have heard a few questions being asked throughout the course of it, and hopefully we'll do that again at some point as well, so you can ask an astronomer if you've got any pressing questions. Keep up to date with everything that's happening at Kielder Observatory on our social media pages and on our website. It's kielderobservatory.org, and of course you can also find all the details of the actual sessions that you can attend on there as well. And keep an eye out for us on Facebook, Twitter and Instagram. Have a fantastic Christmas, and here's to a prosperous and happy 2022. Take care.